Hello everyone. Today we're going to talk about horizontal federated learning. Okay. So horizontal federated learning is used when multiple organizations or clients have different users but same type of features, right? So in this technique, the feature space is same but the sample space is different. Okay. So for example, suppose two hospital 1 and hospital 2, right? So there are two hospital 1 and hospital 2, and they are in different city, right? City 1, city 2, city 2. Okay. So suppose they are trying to predict some kind of disease using this technique. Now, in this phenomena, specific phenomena, so their features are same. Like suppose hospital 1 has some data where they have blood pressure, then weight, height, height is height, and hospital 2 has similar features like hospital 1. But the key difference is that here the users are different. Sorry, the samples are different. Samples are different. Like the data ID of hospital 1 doesn't match, like don't match the data ID of hospital 2. Okay, so these are the major difference. So we have similar features but the sample space is different. So when we have these conditions, like when we have this kind of data, then we can use horizontal federated learning. Okay, so let's understand it by a figure. Yep. So in this example, okay, in this figure there are, you can see, client 1, client 2 up to client n. Okay, so let's suppose each of these clients represents hospitals. Each of these client represents hospitals. Okay, so you can see there are given some features, like these are some kind of features. So across the hospitals you can see the features are same, but here you can see the samples, like each of the sample of different hospitals are different. Like the person whose data are in this hospital doesn't match with the data of this hospital. Like the values can match, but the data ID is different. Like the data of this hospital is different from the data of this hospital. Okay, so in this phenomena, so you can see there are several features. Okay, so across these features, the red mark region are common across all the samples. So these are the common features across all the samples. Okay, so these features can be used to do federated learning. Federated learning, and these hospitals can train their model in their own place without sharing the data to the global model, and then can pass the gradients to the global model, and the global model can aggregate the all the gradients and update the model. Okay, so this is how horizontal federated learning works. Okay, so when we have similar kind of features but the user is different, then we use horizontal federated learning. Okay, so one fun example of horizontal and realistic example of horizontal federated learning is uh, google's Google's keyboard. Like I don't remember the exact name, but they used horizontal federated learning in this Google keyboard. Okay, so we all have mobile phones, right? Mobile phones. Now we all type something using this keyboard. Okay, so in every mobile there are similar features, but the users are different, right? So each mobile has different users, but the features are similar. Okay, So to protect the privacy of users, Google used this horizontal federated learning technique to train their model and in order to predict the next, like in order to predict the future keywords. Like, so as we have similar features and different users, so here horizontal federated learning is used. Okay. To conclude, horizontal federated learning allows multiple organizations to collaborate and work together in training a model while maintaining the privacy. Thank you.